Here there will be liquid of density rho will be present. Fine. So there's a orifice. What do you mean by orifice? Small hole. Orifice A. This there's a piston, or this is what you can call like a plunger or piston. Area of cross section of this is A, that one. So now it is being pushed by a force. Okay, that force will show it here. There's a plane diagram. There's no way you should convert that into plane diagram. This is a syringe, all of you injection, we call injection. No? They do all this. And there's a liquid. Okay, try to analyze now. Okay, the blue color is what? The liquid. So as you push it, what happens from orifice? What do you mean by orifice? Small hole is called as orifice. There's a technical word. Small hole, what happens is called as an orifice. Fine. So do remember that. Yeah. Okay. Now, there's basically our diagram. Okay. Let's display this. Now, where this plunger will be? This plunger. Okay. Fine. Huh? So it will be like this. No, this will be. With what speed the liquid will emerge out from this one. So this will be moving with a speed v1, area of cross section A. There's a liquid of density rho. Okay, all of you able to get this? So here what we have? Air. So here also air is there. Let's apply Bernoulli's theorem between point 1 and 2. Straight away, we'll get into the problem. Why to waste this one? So now, E1, all of you working of this, everything fine?
Yes, sir.
So I think really to fight with the diagram, no, you should understand the physical aspect here. So some of you still what happened in bookish world. You must have the real picture. I'm telling you this one, buy this injection. How much it will cost you? 10 rupees, no? 5 rupees, I think. Purchase one. You'll become good engineer. Definitely. I'll promise you, the more practical ideas you'll get it, the better engineer you'll become. Let's get into writing equation. Bernoulli's theorem. Okay, what is the pressure at this point? P naught plus gauge pressure F by A, because I'm pushing this plunger with force F. So the equation will be P naught plus F by A. Okay, we have like this, no? P1 plus U1. What is the pressure at 1? P naught plus F by A. 1 and 2 are at same level. Then rho V1 square, because the plunger will be moving with the speed V1. Then pressure at 2, it is exposed to air, P naught U. The liquid will emerge out with a speed V2. This, let me give the name. Okay, fine. There's a final equation. Now there's a P naught will get eliminated. So F by A plus rho V1 square by 2 rho V2 square by 2, right? Equation 1. Let's write equation of continuity. Q1 equal to Q2. What is the flow rate at 1? Area of cross section of the plunger A into V1. The liquid will emerge out at orifice with a speed V2. Area of cross section of orifice is A V2. Put 2 in 1. Let's eliminate V1. Let's eliminate expression for V1. So this will become F by A plus rho by 2. V1 I can write it as A V2 by A whole square rho V2 square by 2. F by A is equal to rho by 2 V2 square V1 we have replaced, no? A V2 by this one. Okay, fine. Check this equation.
Sir, it is 1 minus a square by a square.
Yes, sir.
1 minus will come, no? Yeah,
Yes, sir.
1 minus. No, this will be, keep it like this, rho V2 square by 2, A square minus A square by A square. Okay, there's a one, equation 3. You so we want expression for the speed, no? So expression for speed will be 2AF by rho. Okay, this much of speed, what happen? The liquid, what happen, will emerge from the syringe. I am telling you this one. The Western science has not come all of a sudden. They have developed it. They have put effort for years together. Please do understand, science is not something sudden. No, what you are doing is suddenly what when you want the answer. Syringe has come like that only. You see that for that syringe, what happened? You should know the fluids. For fluids, you should know what happened, mechanics. Then if you know fluids, what happened? You should know the Bernoulli's theorem. All everything, no, everything is coming in order. There's a basic science here. So if you don't know basic science, you cannot become engineer. Some of your, I think some 10 days back, somebody commented, sir, what is use of all this? So what all we learn, is it use of anything in future? Tell me, like, if you become some engineer where medical equipments are manufactured, will you just manufacture like that only? So you need all this background, no? So what all you study, what happen, everywhere you'll be using in your field. Getting the idea? This one. So definitely what happen, if you are more practical, general idea, then more better, no? Your thinking. Don't bother rank, huh? Don't bother rank. Instead of all India first rank, if you get 1000 rank also, no problem. But if you have better knowledge. Okay, there's a velocity here. Now, usually, what is the area of cross section of this orifice? Anybody? What is usually area of cross section of the orifice? Will be very small or very large. Small a will be very much capped.
Small, sir.
Very small. Please don't repeat. Don't repeat. Don't repeat. Huh?
Sir, V2 is under root of 2AF.
Under root, I'll put it. Please don't repeat. Again started. Huh? Don't repeat anything. Let only teacher talk. If you have doubt, okay, unmute and talk it, because lot of disturbance is coming once you unmute. Huh? Don't add chorus to the teacher's teaching, please. Huh? Okay, now, what is the next part of the problem is? We'll wind up things here only. Okay, this is about V2. So actually small a will be very much less than this one. So the equation will become, okay, this will be only A will come, no? So 2F by rho A. When this will happen because 2F by rho A. With this much of speed, it will come. So if you want more speed, you should push with more force. Fine. The density of liquid also matters. Higher the, if you, in the syringe, if you put denser liquid and try to press with the same force, it will come out with less speed. You fill up honey, press it, you fill up water in the syringe and press the, move the plung with the same force, then you can see the speed emerge, the liquid which is emerging from the orifice will be different here. Okay, this is about the part A. There's a one answer. Okay, come for second part. It's asking the volume of fluid is V. How much of work must you do to empty the cylinder in time T? How much of work we should do to empty the cylinder in time T? Let me assume some X length here. What happened to value of X? X will decrease with the time. I'll take this diagram. We'll go for the next part of the question. Let V be the volume of the liquid. Okay, no, read the, I think we need all these things. Okay, we'll keep these things in hand. So I'll apply the equation of continuity between the plunger, this having area of cross section, So shall we write A minus dx by dt is equal to A into V2. So further this will become minus A by, so only dx will keep it. Dx is equal to minus small a by A. What was the volume? Volume was given V, no? So what was the initial length? L. So how you write V equal to A into L? So L equal to V by A. Fine. So therefore, initial length was how much at t equals 0? What was the length of the liquid column? L. And finally, it will become 0. This negative will keep it here. So what is V is equal to AL? Initial volume it is. So this will become L is equal to A by capital A V2 T. V2 is what? The speed with which liquid is emerging. Now, what is L? L we can write as V by A. I'll do one thing. I'll write V naught so that it will be easy for us. I'm changing symbol so that you'll come to know initial volume. Okay. So this L, I'll write it as so therefore this time is equal to V naught A V2. What is V2? V2 is two F by rho A. So V naught by A. What we are finding out, I got the time. T is a time taken. So there's a given. I'll write it. Let it be. Here we'll write fresh. After this, what to do? Is asking the work done. No, I'll apply a constant force. What is the displacement? Finally, the plunger, what will happen, will move from left hand to finally when x will become 0. So what is the work done? Work done equal to F into displacement of plunger. F into displacement of plunger is how much? It is equal to L, and we don't know that L. So this F, what we can write it as V naught by E. This is what the work done. Huh? How much of work you must do to empty the cylinder in time t. So if you want, you can replace volume of liquid in this much. If you want, you can replace the F, if you can replace here from this equation, you can replace F and substitute there, you'll get the time T also. Books, they give an answer in terms of that. Okay, I'll just leave it here. There's a work done. So if you want to replace F, you can bring the F. So what is the replacement of F will be A T square by V naught equal to rho A by 2F. So what is F is equal to rho A V naught by A T square. 280 square. That you substitute here. So rho A V naught rho V naught square by 280 square. Okay, this much of work has to be done.
So once can you scroll up, sir? Thank you, sir.
Okay, fine. So these are the different ways of analyzing this particular problem. Okay, now we'll go for the next condition. This is called like a atomizer. Read the question. You have to understand first the basic idea of the question. Just I think some
Sir, A square T square by V naught square.
B naught. Okay, this one. So some here if I B naught square will come, A square will be there. Okay, fine. Yeah. A square V naught square. So this will become V naught cube. Okay, agreed now? Rho V naught cube by 2A square T square. This will be the work done by the force.